These are the notes for AP Calculus on the topic of polar equations continued. So this one says there's a line through the origin with a positive slope. So if it goes through the origin, it's a line, it'd just be y equals, the slope is m, times x, and you wouldn't have a plus b for the y-intercept because it goes through the origin, which means the y-intercept is just 0. So to help us write the equation for this, write an equation using polar coordinates. Let's see what this looks like graphically. So let's draw our y-axis and x-axis here. And let's go back to that first triangle we had. When we were trying to see the relationship between polar coordinates and rectangular coordinates. So notice right here, we're going to draw that same triangle because we really have a linear equation right in here. And where this is the angle theta and this is the y coordinate and the x coordinate. So we're just drawing that same triangle to help us figure out how to solve this. Sorry, I keep tapping on the wrong thing here. Okay. So let's draw our linear equation that goes through the origin. And we could really draw our right triangle anywhere in here. Just draw right in here. Or again, this represents the y coordinate. And this is the x coordinate. And our angle here is theta. So in order to get this equation using polar coordinates, notice one thing with a linear equation that goes through the origin, see how the angle, the radius could be anything, the angle remains constant. So we just have to figure out what this angle is. Notice that's kind of like the equation right here when we had a constant radius of 4. When r equals 4 for polar equations, that created a circle because the radius is always 4 regardless of the angle. So this is kind of like the reverse of that. When a linear equation goes to the origin, the radius can be anything on this line, but the angle is what has to be constant. So to set this one up, it's on that first page of this section of notes also. Notice this is the opposite side, this is the adjacent, so you could say the tangent of the angle theta equals, the opposite is y, over the adjacent is x. In this case, though, we know that y over x, the slope is just, also we can represent it by m. You can even see that if you divide both sides by x in this equation, you can see m equals y over x. So we'd have the tangent of theta equals m. So to solve for theta, to get it in polar coordinates, you would just take the arctangent. You could write it this way, arctangent, or the other way it's written is tangent with a -1 on both sides of the equation. Same thing, just two different ways it can be written. Usually on most calculators, it's written as tangent with a -1. That means the same as arctangent. So if you take the arctangent of tangent of theta, and then the arctangent or tangent -1 of m, then the tangent and arctangent are inverses, so those cancel each other out. So we're just left with theta, which is what we want, equals arctangent or tangent negative 1 of n. As weird as that might seem, that is our polar equation. Notice this is kind of in general form because the slope could be any positive number, arctangent of that number. And this would work even if it was a negative slope. It would still be the same thing. It's just easier to think about as a positive slope. All right, so that's our polar equation. Notice there's no r in here because the radius can be anything. As long as the angle is constant, it can be anywhere on that line. All right, let's look at a more specific example now with a specific slope. So this time we've got y equals, given the line, y equals 1 over root 3x. Write an equation using polar coordinates for this line. So this time we can tell that slope is exactly 1 over square root of 3. Notice again it goes through the origin because the y-intercept is 0. So this time, we think about our triangle here. We can say again, tangent of theta that equals y over x. But again, that's really the same as the slope. We can again divide by the x and see y over x equals 1 over root 3. So we'd have tangent of theta was 1 over root 3. And again, to solve it, you can take the arctangent of both sides. So theta would equal arctangent or tangent negative 1 of 1 over root 3. And to figure out what that is, this time we can actually evaluate. We have a specific slope rather than just m. Well, remember tangent, what we're given is the opposite over the adjacent. So we draw that here. Remember arctangent, we're either going to look in the first quadrant if it's positive, or the fourth quadrant if it's negative, going between negative pi over 2 and positive pi over 2. Remember, it's different depending on which inverse trig function you're using. But for arctangent, it's between negative pi over 2 and pi over 2. We have to restrict where we look so that it's actually a function. Opposite, let's draw that in there, is 1. Adjacent is root 3. So we're looking for what that angle is. And you can see this would be a 30, 60, 90 triangle where this angle is 30 degrees, which is also in radians because you always evaluate these in radians as pi over 6. So that arctangent of 1 over root 3 is pi over 6. So in this case, the polar equation would be theta equals pi over 6. Now let's look at one more where we go the other direction. So now we're given a line in polar coordinates. It's 2 pi over 3. We want to write the equation using rectangular coordinates for this line, the other way around. So again, it helps if you draw this out here. Sorry about that. Okay. So 2 pi over 3 would be in the second quadrant. This is 3 pi over 3. This would be the equation of theta equals 2 pi over 3. So then if you draw in your triangle here, you can see if that's 2 pi over 3, and this is pi, which is the same as 3 pi over 3. Your reference angle would be pi over 3, which is the same as 60 degrees. And when you have a 60-degree angle there, remember the side opposite that is root 3. Notice in this case it's positive. And the adjacent would be 1. That's the opposite of 30 degrees here, but notice it's in the negative x direction, so negative 1. So again, you can say tangent of theta equals y over x. But this time you can see it's the tangent of 2 pi over 3, which we can tell. So the tangent 2 pi over 3 is y over x. Tangent of 2 pi over 3, opposite over adjacent, is square root of 3 over negative 1. And then just to write it the regular way with the rectangular coordinates, this is just negative square root of 3. You could cross multiply here, or you could just simplify that side. And then if you multiply both sides by x, you get y equals negative square root of 3 times x. So that's our equation, or if you want to write it the way it's usually written, y equals negative root 3x. So that would be the equation in rectangular coordinates. Notice the slope is negative root 3 here. You can see that visually because it goes down root 3 and over 1. You can see this doesn't need to have a negative slope here. And that concludes the notes for AP Calculus on this part of the polar equations.